Yes, good morning students. Today we discuss about the relation and function. In the first part, we discuss the equivalence relation. Relation word is common in our general life. We frequently use this relation and comparison between the two or more than two objects. First, we take a relation of two sets. One set is related with three persons, Arun, Ravi, and Prakash. Another set is Anju, Anushri, and Anurag. If we find a relation between this A and B, we can say this that Arun is father of Anju. Ravi is father of Anurag. And Prakash is father of Anushri. You just watch carefully that this particular relation shows something. The father of. And when the relation is concerned, we can represent by R also. Arun, R, Anju, Ravi, R, Prakash, Anurag, and Prakash, R, Anushri. So this R stands for father of. Now, this we can also represent relation in the form of ordered pair, because ordered pair is the most important tool in this relation and function. So how can we write like this? Suppose Arun, Anju, Ravi, Anurag, and Prakash, Anushri. Today, now student, we discuss the relation in mathematics. In mathematics, we take the two sets. Of course, they are non-empty sets, and the subset is represented by A cross B. And that A cross B is a relation from A to B. This is briefly described his relation in mathematics with respect to our set. So, if A and B are two non-empty set, then subset A cross B is a relation from A to B. There are number of relations, types of relations. Empty relation, no element in A cross B. If A cross B is subset to itself, it is called also universal relation. We also say the identic relation. And similarly, we have to discuss a most important relation, that is equivalence relation. And this equivalence relation is satisfied, contains three other relations: reflexive, symmetric, and transitive. If A is non set. R is a relation of A is an equivalence relation if it is reflexive, symmetric, and transitive. Now, one by one, we discuss briefly the reflexive, symmetric, and transitive. First relation we taken as reflexive. In this reflexive, suppose if A is an element of set A, then ARA is also relation, and which is implies that ARA belongs to R. This is the condition of reflexive relation. The second one is symmetric. This symmetric relation, if A, B, there are two sets I am here concerned. A, B belongs to A, then ARB belongs to BRA. Or we can say here also that AB belongs to R, then BA is also belongs to R. This is the symmetric relation. The third relation is we are taken as transitive. Here I have taken three elements of a set A. One is A, B, and C is belongs to R. Then A, R, B, and B, R, C implies that A, R, C means we can say that AB belongs to R, BC belongs to R, then AC belongs to R. Here remember the last element of the first order and the first element of the second order pair is always same, and this is the condition of transitivity. Students, now to solve one problem. Show that the relation R on a given set 1 to 3 is an equivalence relation. For the equivalence relation, we have to find the ordered pairs, or these ordered pairs are 1 1, 1 2, 1 3. These are the possible ordered pairs that is equal to 2 1, 2 2, 2 3, 3 1, 3 2, and 3 3. With these ordered pairs, now we prove that they are reflexive, symmetric, and transitive. So first I am taking to consider the case that reflexive. This 1 1 belongs to R, 2 2 belongs to R, 3 3 belongs to R. Means all these ordered pairs are also a subset of this R. So we can say the relation is reflexive. Now in the second case, that is symmetric. Is 1 2 belongs to R, implies that 2 1 belongs to R. This is also the case of symmetry. Similarly, we can say 1 3 belongs to R, implies that 3 1 is also belongs to R. These all 1, 2, 2, 1, any one of them, 1, 3 or 3, 1, they are also a subset of this R. Now the third case is our symmetric. In this, transitive. So in this transitive, so the relation is symmetric. In the third case, transitive, if 1, 2 belongs to R, then and 2, 3 belongs to R, then 1, 3 is also belongs to R. The relation is transitive. Now the relation, given relation is reflexive, symmetric and transitive. Therefore we can say yes, the given relation is an equivalence relation. The given relation is an equivalence relation. This is the completion of this our equivalence relation. In the next part, we discuss the inverse function. Okay, goodbye.